Let's discuss problem A. Make it 0. Div2 problem A. In this problem, you are given an array of integers, and you have an operation. During an operation, you take a subsegment of the array and replace each number in this subsegment with the XOR of this subsegment. So, for example, if we have A1, A2, A3, A4, A5, A6, and we apply this operation for L equals 2, R equals 4. In this case, we get A1, A2 XOR A3 XOR A4, again A2 XOR A3 XOR A4, and once again A2 XOR A3 XOR A4, and then A5, and then A6. The task is make the array consists of all zeros. How to solve this problem? Actually, the first thing that you might try to do is some border cases, corner cases. So the easiest way to do something is to try and do operation with one element. And alas, it doesn't do anything, yeah, because the XOR of one element is still this one element. So you replace an element with itself and you do not change the array. The second thing that you might try is change the whole array. So if you have A1, A2, etc., AN, then what do you do via an operation? The first operation will actually make all the elements same, yeah, because each element will be just equal to the XOR of all elements. So you will get S, 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 etc. S, where S equals the XOR of all elements. So what will happen if you do the same operation next time, again with the whole array? What you will get is, it depends actually on the parity of n. Yeah, because you will get S XOR S, XOR S, etc., XOR S, where S is taken n times. And this element will be put on each place. So if n is even, then this is 0. I will do like this. So it is 0 if n is divisible by 2. Why? Because you can divide these s in pairs, and in each pair the answer is 0. And the operation of XOR is associative, so you can rearrange this chain of operations so that you do these operations in pairs. So in each pair S XOR S is 0, and you get overall 0. But the problem is that if you have an odd n, then it will not be equal to 0. It will be equal to S. Still, this is not really a problem, because we have solved the problem for even n. What do we do with odd n? In case of odd n, actually, you cannot make, in two operations, you cannot make the whole array zeros. But what you can do is you can make the whole array except one element zeros. So let's stop here, for example, yeah, at element a n minus 1. And in two operations, as described before, you can make all zeros and an. So in the end, you can actually take any even suffix, either, for example, this one or this one, anything you like, and you fix this even suffix. Okay? So this is actually the solution to this problem, and let me write the solution. So first of all, we need to read number n. Then we need to read all numbers ai. I use vi. Vi means a vector of ints. I can actually write it properly. Then you read all numbers. But actually you do not need these numbers. The only reason why we read these numbers is because if we do not read them, we cannot access the next n. Yeah, actually we do not need anything from this array except number n. This is the only thing that is important to us. So we will not use this array v at all. So generally you can just do it in 4 operations. You can always do it in 4 operations. So first of all, you choose the whole array, but in even case, but in odd case, you subtract 1. It can be written like this. So you need to take let me think. You can do it like n or 1 SOR 1. If you do it like this, you will always get either n if it is even or n minus 1 if it is odd. The second operation might be the same. And the last two operations can be, for example, n minus 1 and n. Also, you need to print the number of operations that you use. So before all of this, we need to print 4. Let's try what we have done. For example, for even number 4, it just did these operations 1 4 1 4 and then 3 4 3 4. It is completely okay. Even if the array is even, so after these 2 operations you got all zeros, you can still do any operations you like because it will still leave the array full of zeros. Actually, if after the array is 0, you cannot change it at all. The same goes for 8, because you get 1 8 1 8 7 8 7 8. And in case of 6, 1 6 1 6 5 6 5 6. And interesting, for example, is this array 5 and 5 zeros. In this case, we need 1 4 1 4 and then 4 5 4 5. So these 2 operations make the first 4 element zeros, and the last 2 operations make last 2 element zeros. So this works. We can check it actually. Let us check it. And we get accepted instantly.